The data from NASA's InSight mission points to the urgent conclusion that a massive water reservoir is dormant beneath the surface of Mars, making it one of the most remarkable reports in recent space exploration. The reservoir might even be 1 to 2 kilometers high, which would be enough to flood the entire planet. Experts believe that there may even be Martian life still sleeping in the pores and fissures of the Martian crust, where the chilly water is concealed. It is no accident that Mars is sometimes referred to as the red planet. Iron oxide dust actually covers the surface of our planetary neighbor, giving it its distinctive color. It's a pretty dusty calling card, but it fits very well with the arid and frigid face that Mars currently displays to us. But if we look back at least 3 billion years, we find that Mars used to be considerably more rippling. It is now accepted that rivers, lakes, and even entire oceans once decorated the celestial body. According to calculations, up to 75% of the planet's surface might have been submerged under the Martian waters. However, not much of the once liquid face is left after a few significant climate shifts and the removal of the dense atmosphere. However, the end of the Martian era, which was favorable for life, also begs the fundamental question: where did all of the red planet's waters truly vanish to? The polar ice caps of Mars are really too small to hold all of the water from the past oceans, according to the data gathered thus far. This also holds true for the water ice deposits seen below the surface in mid-latitudes. In light of this, the majority of scientists believe that the red planet has merely emptied the majority of its water supplies into space. The absence of a magnetic field made it simple for the solar wind to carry water and other components of the planet's atmosphere into space. The theory is a waste. Ultimately, however, there is another hypothesis that finds the Martian water on the planet but nowhere else in the universe. Vashon Wright of the University of California, San Diego, led the team that analyzed the data from Marsquakes obtained by the seismometer on NASA's InSight lander from 2018 to 2022 to determine whether the water in the Martian oceans could have retreated into the depth of the stony crust. One may assume that the venture was not very promising, as the seismological data had previously demonstrated that there is very little water in the Martian crust down to a depth of 300 m at the InSight site. However, there are situations when you really need to look farther. Wright and his associates concentrated on the celestial body's central crust, which lies concealed between 11.5 and 20 kilometers below the surface. Furthermore, these subterranean areas might be sufficiently heated to support perennially liquid water near the upper border of the Martian middle crust, despite the planet's 68°C average yearly temperature. Additionally, earlier studies had already demonstrated that numerous rock pores could be found throughout the desired crustal region. The scientists carefully examined the seismic data as part of their investigation because it might provide insight on the composition of the middle crust. The mathematical model of rock physics utilized here, for instance, is used to find oil deposits on Earth, but it should reveal something on Mars that was thought to be impossible only a short time ago: enough water for an ocean that spans the entire planet. In the end, the examination of the seismological data revealed two things. First, it confirmed that the Martian midcrust is porous as predicted, with the holes accounting for about 17% of the rock. Second, it revealed that liquid water is indeed present in the tiny fissures and pores. In this regard, Wright's team concluded that a middle crust of fractured magmatic rock that is soaked with liquid water best explains the evidence they gathered. To put it another way, a massive liquid water reservoir may exist 11-20 kilometers underneath Mars' surface. There is still a minor but attached to this great news, though, as it only holds true if the findings are indicative of the remainder of the planet, as well as the location of the Mars rover. But if this is true, Mars might have had a deposit of groundwater in its rock pores that was big enough to create an ocean that would cover the entire planet. Furthermore, the volume of water might even be sufficient to flood Mars' whole surface, which is between 1 and 2 kilometers high. Given this context, the invisible reservoir may also help to explain the fate of the water in the extinct Martian oceans. Rather than being lost due to air outgassing, it seeped into the Martian crust's depths and has since been preserved as pore water. However, it is incorrect to assume that Elon Musk can currently supply the drinking bottles for Mars' future residents. Since drilling equipment cannot reach such high depths, future Mars tourists and stations would actually be unable to access the water reserve. However, life has the capacity to go to such extremes. Antarctic researchers were shocked in the spring of 2021. Drilling into the supposedly Filchner-Ronne ice shelf eventually resulted in the startling finding of sedentary animals that somehow survived 900 meters below the surface, away from any sunshine and without any discernible food source. Then there is the so-called deep biosphere, a mystery realm of life that is developed in the Earth's basement. Although this is primarily composed of bacteria, viruses, and fungi, these microscopic survivors have already been found in volcanic rock, ocean sediments, and even the solid bedrock of continents. Given this, you would believe that the well-known statement from Jurassic Park, "Life always finds a way," truly describes reality, at least on Earth. However, what about the Martian water that is hidden? Is it possible for life to flourish in the harsh subterranean environment of the Red Planet? The researchers' succinct yet insightful response is, why not? According to co-author Michael Manga of the University of California at Berkeley, I don't see why the subsurface reservoir of Mars wouldn't also be a life-friendly environment, since water is a prerequisite for life as we know it. Although scientists haven't found any proof of life on Mars yet, we now know of at least one location that could potentially host life. Assume, however, that microbial life does, or once did, exist on Mars. So why haven't we been able to find the little Martian signatures yet? In actuality, though, we might have already done so. Are they the remnants of microorganisms from Mars? Since landing on the Red Planet on February 18, 2021, Perseverance has spent the last 3.5 years investigating the terrain and rocks in the Jezero crater. The primary mission of NASA's rover is to gather soil samples for subsequent return to Earth. However, Perseverance is also keeping its technical eyes peeled for any signs of past Martian habitation. Indeed, a few weeks ago, NASA declared that the rover had made a groundbreaking finding in this area. In the northern foothills of the historic Neretva Vallis River Basin, Perseverance has located a remarkable rock feature known as Chava Falls that is ornamented with wide white sulfate veins. The presence of the iron oxide mineral hematite is indicated by a deeper reddish substance that lies between them. Theoretically, this happens in vast numbers on Mars, but it does not apply to the few irregularly shaped millimeter-sized patches in the deposits, which are filthy white in color with rings of black material that contain phosphate and iron. Measuring about 1 m in length and 60 km in width, the rock represents the first unambiguous indication of organic matter on Mars. The theory that the colored patches might represent chemical events that microorganisms employ to generate energy is very intriguing. In fact, spectrometer studies have revealed the presence of organic carbon molecules in the spots and their surroundings. In summary, the stain pattern resembles the marks that bacteria usually leave on Earth when combined with iron and phosphates. In specifics, these deposits are frequently linked to the fossilized remains of subsurface microorganisms, which release phosphate and iron as they break down iron oxide. Additionally, there is convincing evidence that water formerly flowed over Chava Falls, allowing Martian bacteria to thrive there. However, what are the true meanings of all these points? Has the existence of extraterrestrial life been conclusively demonstrated by Perseverance? Well, not always. NASA notes that while bacteria are frequently the source of organic compounds on Earth, they can also originate through geological processes that do not require living things. For instance, during volcanic activity, this is feasible. We just do not yet know how Chava Falls developed or whether lava had any role in its formation. But regrettably, the specialists have now used up all of their distance sensing options. They have photographed the rock day and night from every possible angle and have blasted it with lasers and X-rays, according to their own words. It must be transported to Earth in order to truly comprehend what lies beneath the boulder. There, a thorough examination using highly accurate equipment might ultimately determine whether the Martian rock is truly covered in prehistoric signs of life. Additionally, you may now add fresh click marks to the subscription button. Please give us a thumbs up and subscribe so that you don't miss another thrilling video from us. See you soon.